Everybody, Mr. Buckley here with number 18 and number 19 from one of the geometry review packets. Number 18 is up on the screen where we have in the figure, S is an image of R under a transformation, and that's very important to note here, is that S is the image. So what that means is that we start with R and we're ending with S. S is the image of R under a transformation. So when you look in a mirror, your reflection is the image of yourself, and in this case S is the image. So S is what we're ending with here. It's the image of R under a transformation. And we're going to write a transformation, or write the transformation, as a composition of reflections over lines A and B. So if we're starting with point R, we can see that if we reflect R over one of the lines, and you can kind of explore with that a little bit, but if we reflect R over A, R is going to end up right here, and I'll put a dot right there. This is R being reflected over A, and then if we take this red dot here that I just reflected with R, and I reflect this over B, it will end up right where S is, because this red dot is 1, 2, 3 units away from the line B, and the image S is 1, 2, 3 units away. So if we take R reflected over A, we get the red dot. If we take the red dot reflected over B, we get S. How do we write that? Well, the first thing we did is we took point R and we reflected it over A. And again, we're kind of working backwards with reflections. We work backwards, and the notation is no different. So take R, reflect it over A. That's what we did first. After that, another reflection we're going to do, so we're going to use the composition symbol right here, which you can just think of as and then. So we took R, reflected over A, and then we reflected this point over B. So we have the reflection over B. So we took R, reflected it over A, and then we reflected it over B, and we ended up with point S. And you could say that this equals S if you wanted to, but this is the notation for, or this is sufficient to say that this is the point S, because we take R, reflect it over A, and then reflect it over B. If we were to write this transformation as a translation, including direction and magnitude, that's a vector. So if we're starting at R, and we're just going to move it as a translation, it's just moving. If we take R, how did you move R to get to S? Well, we just moved R up. Well, how many did we move it up? We didn't move it any left and right, so the left and right movement is 0. And the horizontal movement is 0, and we moved it up, and we could just count how many did we move it up. We moved it up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the vector would be 0, 10. We took this point R, we moved it left and right 0, and we moved it up 10. So this would be the transformation as a translation, including direction and magnitude. This is sufficient to say that this is the vector for which we moved RS. Number 19, same kind of idea, just two different lines. Write the transformation as a composition of reflections over A and B. Once again, S is the image of R. So we're ending at S, we're starting at R, and we can kind of go either way here. So there's going to be two different ways to write this. If I take R and I reflect it over B, ends up right here. 1, 2 away, 1, 2 away. If I take this red point and reflect it over A, I would end up at S. So we could say, well, we took R, we reflected it over B and ended here. And then we reflected it over A, and we ended up at the point S. And that doesn't line up very nicely, but couldn't get that point exactly there. But this point, if we reflected it over A, 1, 2, 3, 4, 5 away, 1, 2, 3, 4, 5 away. Or we could take R and reflect it over A first. If we take R and reflect it over A, we'll end up about right here. Put a dot there. And then reflect that over B, we end up at S. So we could say that we took R, we reflected it over A, and then we reflected it over B. That would be the same thing. Either one of these two is just fine. Either one of these two compositions would end up with R ending at S. Write it as a translation, including direction and magnitude. Well, we started at R, and we first went left 1, 2, 3, 4. So went left 4, and then we're going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went left 4, down 10. This notation would be negative 4, negative 10, if I could write that appropriately, is what that should say. So here's all our points here, and we should have -4, -10, because the left-right movement we do first. So we go -1, 2, 3, 4, and then we went down 10. So from R to S, that would be -4, 10. Sorry for that typo there, but that's what that would be as a vector.